Welcome to HP Tuner's GM Gen 5 training part 24. In this training module, we're going to be taking a look at working with our torque modeling system once again. This tutorial, we're going to be focusing on going into our VCM scanner, taking a look at some log data, and understanding some general rules we have within our torque modeling. So if we get throttle closure or spark timing reduction under full throttle conditions, we know which part of our torque modeling that we need to go after to correct. We're gonna have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're gonna be taking a look at working with our torque modeling in our GM Gen 5 applications. Our last tutorial focused on the overview or the basics of the torque control and how it worked in our Gen 5s. This tutorial, we're gonna be digging into things a little bit further, taking a look at our VCM scanner and looking at specific channels that'll allow us to evaluate what's going on with our torque-based control. Based on what those parameters are showing us, we're gonna find some trends that we are able to spot that I'm going to be sharing with you here that'll allow you to understand how the torque control is working. So if we get throttle closure or spark timing retard as a function of torque management because we're exceeding a torque limit, we need to go and correct that torque limit or correct that torque imbalance in our torque modeling. There are some specific areas that we can do that. Virtual torque is going to be one of those areas that we can make some corrections. There are going to be some other areas that we're going to be talking about here in the tutorial to get things back in line. So let's jump in here and let's talk about and take a look here real quickly at what we have going on for our torque control. Then we'll jump into the VCM scanner and take a look at a few data logs. So calibration file I have open here is from my Yukon Denali. Doesn't really matter which Gen 5 calibration file you're opening and looking at. We'll have access essentially to the same torque-based tables in all of the Gen 5 calibrations. If I jump in here to engine and we move across here to torque management and then we go here into our driver demand, we know that the map A normal table here is where the torque request starts. This is translating an Excel pedal movement into a torque request. Now this table here is based on axle torque. We talked about what that means for trucks and SUVs. It'll be based on axle torque. And then if you'll find the Camaros and Corvettes are usually based on engine torque. Now different calibration strategies, different year make models for GM will be different. So this is going to be depending upon your calibration. This is from my SUV here, which is based on axle torque. So it's a function of pedal input, the Excel pedal, the electric pedal in the car, and the speed up here at the top. So as we're starting here on the lower range of the table at our higher throttle angles, we'll find first, second gears, what this represents. This is going to be right here, giving us a higher torque of value because it's showing multiplying through the transmission and what's going out to the actual axle torque, what's going to the wheel. And then as we start to pick up speed here, we shift through the gears, and this is a 10-speed transmission, and we're gonna find that that torque starts to dissipate here as we go up faster and faster because we're getting up closer to 1-to-1 or sub 1-to-1 gear ratios. So that's gonna be how this works. This is axle torque. So gear ratio multiplied by final drive multiplied by engine torque, that's what's sent to the actual wheels. This translates the pedal input, electric pedal input, to a torque request. Now that torque request, as I mentioned in the previous tutorial, is fed into a torque model, and we'll find we get an inverse out of that, which is going to be a desired MAF, which is going to translate into a throttle plate opening. And what that's going to do is allow us to have a point where the throttle plate's going to open at, and then we'll compare that to the actual mass airflow and actual map pressure, comparing the desire to the actual, and then we can start to take control over that, control over the throttle plate in the drive-by-wire routine. So the torque-based modeling is used to control the engine's torque output, and it's primarily going to be used to drive the throttle plate opening or closing, and it's also going to have spark timing as a function of the torque control. So we've talked about predictive control and we talked about immediate control. The immediate is going to be spark timing retard in terms of torque management. The predicted is going to be our throttle plate opening. So we have a slow response, fast response. Immediate's fast response, predicted is slow response. So we're gonna have those two different aspects that are gonna be finding for control. Now this particular table, the driver demand table, this is going to be driving what's known as the predicted torque. The immediate torque will also follow suit, but the driver demand table here will be driving that predicted torque. And we'll talk about how that relationship is going to be going here in our VCM scanner. There's some things that we want to take a look at. So if you're on a Corvette Camaro, you're probably likely to have the engine torque here in the table. If you're on
truck or SUV, you're most likely going to have axle torque here.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.